The next algorithm is least recently used. Now, this algorithm works in a slight different way. We cannot look in future, we cannot understand what future might have, but definitely we understand what past has done. There is a saying that don't worry about the past because there is nothing you can change. Don't think too much about the present. Don't think much about the future because that is unknown. What you have is present. So now least recently used does much of the same way, but with a slight twist. It does learns from what past has happened, or rather what has happened in past. Means what? The basic ideology in least recently used is remove the one that is not referred. Remove the first that is not referenced from long time. From long time. That means if we have a page which has not been referred by any of the process for a long time, we will remove that. This is much similar to FIFO, but FIFO the difference is only at the time of page inserting the RAM and we are or not considering any other thing. Whereas in this, how soon or what was the last when a particular page was used will be kept. This information will allow them to serve who should be treated or who should be replaced. Let's see example again. Last time we also have 3 slots in this. After 3 initial page fault, everything comes and stay in data. Let's start with it, guys. What we have: initial page fault 1 enters, initial page fault 1 2 enters, initial page fault 1 2 3 enters. Chalo, done. Now let's start. These 3 are gone. We have 4. So let's see. Out of 1 2 3, 1 was referred 2 frames back, 2 was referred 1 frame back, 3 was referred just last. So obvious 1 was referred 2 frame back. So we'll replace 1. We have 1 2 3, out of which we will replace 1 by 4. Again page fault with replacement. Going further, what we have now is 4 2 3. Next one is 1 again. Now if we see which wasn't referred for a long time, so we said 2 was not referred for the long time, so that in that case 2 would be replaced by 1. Going further, what we have now is 4 1 3. The next one going is 2. Again in this case we have 4 which was referred 2 frames back. We had 3 which was referred 4 frames back. So the next one can be targeting 3 and keeping 2 in it. So next thing we have is again 4 1 2. Going in is 5. Out of 4 1 2, if we see back, what we have is 1 which was referred. We have 2 which was just referred. 4 was not referred for a long time, so that can be treated as the least used. So we can replace that now. 4 will be replaced by, going one step further, 1. So we have 5 1 2. Sorry guys, color change karo. We have 5 4 1. Next thing going in is 1, but there is no page fault because 1 already exists. Next one is 2, so we have 5 4 1. Let me put it straight, guys. Now we have 5 4 1. Next going in is 1 which already exists, so no issues. So again we have 5 4 1. Next entering is 2. In this case 1 has been just referred, 1 has been just referred, 5 has been just referred, 4 has not been referred for a while. So we will simply replace 4 with 2. So next one in the series goes in is 3. What we have is 5 2 1. So 3. Now what 3 would replace? 2 which was just recently accessed, no. 1 which was just recently accessed. 5 which has not been recently accessed. We'll replace it by 3. Going further, what we have in hand is currently 3, 2, 1. Now let's try to see the next one is 4. When we talk about the 4, let's understand 4. 3 cannot be because it is just used. Then talk about 2, again used. 1 compared to 2 and 3, 1 was not much used, so we can remove 1 and swipe it out with the new data. That is in our case 4.